Here we go. We're going to start off with number 19. All right, number 19. So, in number 19 it says restrict the domain for the following function so that it has an inverse, and then find the inverse. First of all, remember, in order for a function to have an inverse, it must be 1-to-1, meaning it must pass the horizontal line test. All right, if I think about this graph, my parabola is going to shift 6 units to the left and then 3 units down, so it'll look like this. Right? But we always only want one part of it. I only want the positive half. All right, if I only include the positive half, okay, my function will be 1-to-1. It will pass the horizontal line test. So I'll say x is greater than or equal to -6, or I could write -6 to infinity. Okay? In order to find an inverse now, remember this is the same as y equals. All right, it's the same as y equals x plus 6 squared minus 3. Okay, so what I need to do is I need to replace x with y and solve for y. So now I have x equals y plus 6 squared minus 3. Add the 3. X plus 3 equals y plus 6 squared. Square root both sides. Technically, y plus 6 equals plus or minus square root of x plus 3. Subtract the 6, y equals technically plus or minus, and I'm going to talk about that in a second, minus 6. Now, again, since we're looking at the positive part of our function, I don't need the plus or minus, I just want the positive answer. Okay, so my domain would be square root of x plus 3, or my function, sorry, my inverse would be minus 6. And to restrict that domain, I want to go from -3 to infinity, including -3. All right, or x is greater than or equal to -3. Okay. All right, let's keep going. All right. Next, I want to find the domain in zeros of each function and place our domain in interval notation. All right, so the domain, remember, when I take the square root of a number, I cannot take the square root of a negative number. Greater than or equal to 0. All right, so our number must be positive. Okay, so we're going to set whatever is underneath the square root greater than or equal to 0 to make sure that it is positive. So I'm going to subtract 4 and divide by 3. X must be greater than or equal to -3. -4 over 3. So my domain goes from -4 over 3 to infinity. Okay, my zeros. My 0, I'm going to set my function equal to 0 and solve. Well, to get rid of the square root, I square both sides. Holy buckets. All right. 3x plus 4 equals 0. Subtract the 4. 3x equals -4. Divide by 3. So I get -4 over 3, comma 0. Boom. Boom, pow. All right. Next, I want to solve for the domain. Well, this is a reciprocal function-ish. All right. So in this function, I have my denominator. I'm going to set my denominator. I cannot divide by the number 0, meaning my denominator cannot equal 0. Okay, so let's solve for the number that cannot equal 0 for x. 81x squared cannot equal 25. Divide by 81. X squared cannot equal 25 over 81. Square root, square root, square root. Excuse me. X cannot equal, plus or minus, since we're solving, 5 over 9. Okay? So I already know this is going to be a long one. So x cannot equal plus or minus 5 or 9. It can equal any other number. This is going to be long for my domain. I'm going to put it in red. All right. Negative infinity to -5 over 9. Union. Hopefully I can fit it. -5 over 9. to 5 over 9. Union 5 over 9 to infinity. All right. To find my zeros, I set my numerator equal to 0 and solve. All right. A common mistake that people make is they always just set this one and make that 5, 9, comma 0. Do not do that. Set your numerators at the top equal to 0 and solve. Okay. Our denominator cannot equal 0. So wouldn't it make sense that that number is our 0? 5 over 9 cannot be a 0 and be in that domain. My number is 9 over 4, comma 0. For my zeros. All right. Cruising. 21. Oh, buckets. Here we go. All right. So, transformation problem. Okay. Originals. We've done these originals a lot, haven't we? Okay. -2, -2. -1, 2. 1, -1. 2, 3. Those are my original points. Remember, we work from the inside out. First thing I'm going to do is take care of this plus 2, so that's going to be left 2. So I'm going to subtract 2 from my x values. -2 minus 2 is -4, -2. All right, go ahead and do that. All right, so remember I moved left 2. I subtracted 2 from every x value. Now I got to take care of this 2. The 2 is attached to the x, which makes it a horizontal shrink by 2. So I'm going to take all of my x's, since on the inside do the opposite, and divide them by 2. So my first point would be -2, 2. Go ahead and try the rest. All right. Next one, I got to take care of this negative out front. Remember, if it's out front, I'm going to reflect over my x-axis, which means I'm going to take all of my y's and change the sign. So I'm going to make this -2, +2. -1.5, -2. I'll just keep going. -1/2, 1, and 0, -3. Last thing I'm going to do is go up 1. All right, which means I'm going to add 1 to every single y. -2, 3, -1.5, -1. These go, -1/2, 2, 0, -2. And plot our points. -2, 3, -1 1/2, -1, -1/2, 2, looks something like that. Alright. There's 21. 22! Ooh. I'm pumped for 22, aren't you? I think I was really loud on that one. Alright. So, getting a little too pumped up here for some math, you know? Feel me? Okay, here we go. So, to test if a function is even, odd, or neither, remember, for even, I'm going to take x and replace it with -x. And I'll get my original function. For odd, place x with -x, and I'll get the opposite of my original. So if I take f of -x here, that's 2 times -x squared plus -x to the 4th. Well, anytime I square a negative, it becomes positive. Square a negative, it becomes positive. So this is my original, which is my f of x, so it's even. Write an equation of a circle that has the endpoints of the diameter, that. So remember, our equation of the circle is this. So I must know my center and my radius. To find the center, I need to find the middle of those 2 points, or the midpoint. So how do I find the center? I add my x's and divide by 2, and add my y values and divide by 2. And I should get as my center is -7 plus 5 is -2. -2 over 2 gives me -1. -1 plus 9 is -8. -8 divided by 2 gives me -4. So that's my center. So now I'm going to, so I have x plus 1 squared plus y plus 4 squared equals r squared. So I need to solve for this r squared value. So I'm going to take one of my points. I'm just going to choose this one here and plug it at point in for my x and y values. -7 plus 1 squared plus 1 plus 4 squared equals r squared. Well, I know that -7 plus 1 is -6. -6 squared is 36. Remember, if you're using your calculator to do that, use parentheses. Plus 1 plus 4 is 5. 5 squared is 25. Equals r squared. R squared equals, what is that? 61. Now, don't take the square root of both sides to find r, because all we need is r squared. So once we have r squared, my equation becomes x plus 1 squared plus y plus 4 squared equals 61. All right. Last one of the day. Contain yourself. Try to hold back your tears. I will too. I know that x minus 36, x squared minus 36 is x plus 6, x minus 6, which means I'm going to multiply everything by x minus 6, x plus 6 over 1. Okay? So why don't you try and do that? Go. If I multiply every single term by that, by this here, I get x 4x plus 6, x minus 6. So my x minus 6 cancel, and that's what's left over. Here, they both cancel. So I'm just left over with 72. On this side, my x plus 6's cancel, so I'm just left over with x minus 6. Now remember to distribute here. So it's 4x plus 24 plus 72 equals, distribute, x squared minus 6x. I'm going to have to factor, so I want to move everything to this side. Alright, so I get 0 equals x squared minus 10x. If I add these two together, I get 96 minus 96. Factors of 96 that'll add to give me -10, x minus 16, x plus 6. So x equals 16, and x equals -6. But wait, remember you have to check for extraneous solutions. So if I plug in 16, 16 checks out on the bottom here, my denominators. If I plug in -6, -6 plus 6 will give me 0. So -6 I can throw out, and my answer is 16. All right, happy